Hello everyone, welcome to another learning session. This is a very important learning session, and today we are going to continue to learn about systems design fundamentals. We had the first session where we discussed about the most important core concepts. Then we had important characteristics that are needed for systems such as availability, scalability, and all those things. And then we had part 3A, where we discuss some of the concepts and components that can help us improve those characteristics. And today we'll be learning a bit more of concepts and components that can help us in improving those characteristics. Systems Design Fundamentals 101 Part 3B. We'll be discussing about topics such as replication, sharding, leader election, polling, streaming, rate limiting, monitoring. Just in case, if anybody is new to these sessions, I am Hartin Kanagatotu, and I have written few books, and I have got this award of Best 8th Cloud Computing Book of All Time. And also I have some Microsoft certifications, and I am also a Microsoft certified trainer. You can learn all about me from hartin.github.io. This session on systems design fundamentals is part of a study group session. It is not a course, and it can be called as a study group session if and only if all the members of the study group participate. Otherwise, it will be just one-man show. So today, in part 3B, we'll be discussing mostly about these things like replication, sharding, leader election, messaging, polling, streaming, rate limiting, monitoring, etc. So what do you mean by replication? So replication copies data into more than one location. We are learning concepts and components that can help the characteristics. And these characteristics include availability, scalability, and a lot of things. And replication is one of those components or concepts that can help you improve your availability. We have more than one system. Then even if one of those systems go down, then the other will be still available. And if you have systems replicated across regions, then if one region goes down, then you can bring up the other region and then business can continue. We have learned about concepts such as fault tolerance and disaster recovery and all, right? And we also looked into some examples from cloud providers. For example, if you are replicating within a region into multiple availability zones, a cloud provider such as Azure will give you a better availability guarantee or better SLA compared to deploying it into only one machine. So if you consider the example of Azure Cloud, then if you are deploying it only into one data center or one availability zone, then you will get certain SLA or certain availability. And if you are replicating across multiple availability zones, which effectively means multiple data centers, then you get a better SLA or better availability than just a single data center or just a single availability zone. And if one of these data centers go down or one of these availability zones go down, then your operations will continue, your business will continue, and this is usually referred to as fault tolerance. And if you have enabled replication across regions, and if your whole region goes down, then you can immediately bring the instances in another region. And this is usually referred to as disaster recovery. In all these cases, replication is important. Replication can be done synchronously or asynchronously. Synchronously doing replication can give you consistency, and doing it asynchronously can give you better performance. So synchronous means if I am writing to one of the machines, imagine that I have machine A and it has two replicas B and C. If I am writing to A, it will synchronously write to B and C, and then it will tell me, okay, everything is written and perfect. And if somebody else reads from B or C, they will get the latest data, and that is called as consistency. And what about asynchronous writes? I am writing to A, and immediately after data is written to A, it will tell me that, okay, it is written, you can continue. And then in parallel, asynchronously, it will write to B and C. So during this time, when I have already written to A and I am going ahead with other operations, there is a chance that somebody will read all the information from B or C. So that is a risk you have to take with asynchronous writes, but the performance is better here. As an architect, you always have to make some trade-offs, right? You have to always take decisions based on trade-offs. So this is also one of those examples. And then replication increases availability. And at the same time, replication can also increase latency, especially in case of synchronous writes. If you are writing to A and if you are waiting for it to write to B and C, there could be some latency issues. As a quick assignment, you can list down all real-world use cases where synchronous replication is needed and where asynchronous replication will also work. You can Google for these things, and then you can comment under the YouTube video. When you search for something in Google, you are not only going to learn about those things, you are going to learn a lot of other things, or at least you are going to see a lot of other things around, and that can really improve your breadth of knowledge. Work on these assignments for a little bit of time daily, and then you can become very good with systems designs. Sharding. So replication means I have some data, that whole data is moved to various different locations. And if I have a huge set of data, there could be performance issues also, right? And to improve upon those areas, especially on the performance side, what we can do is somehow we can divide this data. Imagine that I have data belonging to the whole world. Maybe I can divide that data based on countries. And when I know that, okay, this data belongs to this particular country, then I have to only look into that particular set of data. How many of you remember from a previous session about hashing? I had explained with respect to the students of a class, and I had talked about buckets or groups and all, right? Okay, so whenever we are looking into only a smaller set of data compared to the whole set, performance is definitely going to be better. And that is the whole idea of sharding. So the whole data is horizontally partitioned. Horizontally means different rows are taken. Okay, maybe rows pertaining to one country, or maybe some other parameters can be used for creating these shards or partitions. And then the same logic will be used for querying as well as writing every time. And then you have to only look into a subset of the whole data rather than looking into the whole data itself. Each of the shards will share the same schema. So here, the number of columns and the column names and all will be same for all these shards. There are various strategies for sharding, like symbol hashing, consistent hashing, and it is similar to load balances that we learned in our previous class. So tell me, is partitioning same as sharding? Yes or no? Partitioning and sharding. So partitioning is a generic term for dividing data across tables or databases. And partitioning can be done vertically or horizontally. Vertically means some of the columns, meaning some of the fields for all customers or all users will be moved to a different machine or a different partition, and some of the other columns or other fields will be moved to a different partition, maybe a different machine. The advantage of such partitioning is that you can do aggregations on data much faster. But whenever you want data specific to a particular user or particular customer, then that kind of partitioning will not be good enough. And for getting all data with respect to a particular customer or with respect to a particular set of customers or a group of customers, you need horizontal partitioning. Basically, you will take data for a set of customers, maybe customers belonging to a country, to a particular partition. So that is called as horizontal partitioning. So sharding is a horizontal partitioning technique, and hence it is a subset of partitioning. But many times, many products use just the term partitioning to refer to horizontal partitioning, unless otherwise mentioned. So you may see these terms here and there, but you should understand what they are behind the scenes, whether it is horizontal partitioning or whether it is vertical partitioning, and when are these things used, and what are their use cases. This basic information you should have, some of which you should have already got when you attended the session on NoSQL databases, right? A question for everybody who attended the hashing session or the load balancers session. Can a consistent hashing save us from a shard failure? First of all, a simple question, can a symbol partitioning save us from a shard failure? And second question is, can a consistent hashing approach save us from a shard failure? I'm assuming you attended the previous session and you have all knowledge about hashing, symbol hashing, consistent hashing, and how they are used in the real world for load balancing. If not, and if you are watching it over YouTube, then you can pause and then go and watch it, and then you can come back, answer it, and then you can proceed. With respect to load balances, we saw that for certain use cases, symbol hashing cannot save, especially when a server fail. If 99% says answer is A, then in most of the cases, it is going to be B for us, right? So those are the kinds of topics that we are discussing here. To make sure all those 99 can now understand the same as that 1%. And if you are not able to understand, please ask now or later in our study group. Okay, so what does hashing or consistent hashing do? They will send you to the right server. And here we are talking about data, not just servers. So if I have a list of users, say from our CloudRix community, and I am using some kind of hashing algorithm so that all data for members starting with the name H will go to one particular shard. So my data will be only applicable in one shard, right? So the name Hartin will be only present in one shard, right? So if that shard is gone, will symbol hashing or will consistent hashing can do anything? Consistent hashing can route me to another server, but will that help? No, right? The data for Hartin will not be present in that other server if we are only doing sharding. And by default, consistent hashing, when used with sharding alone, cannot help if one of the shards fail. That is where we will have to mix and match. We'll have to use both the replication and sharding together. We'll have to shard data, and we'll have to replicate these shards. And there are many popular architectures that are based on this concept. If you Google for the sharding and replication architecture of Elasticsearch, you will understand these things better. Node will have a replica shard as well as primary shard. And if one node is gone, then some other node will have the replica of these two. So in a way, your business can continue. So whenever you learn these concepts, try to apply it to different components. Yesterday, we applied hashing and consistent hashing and all to load balances. Today, we are applying it to shards. So replication and sharding together, replication and sharding can be done together. So consider primary shards P1, P2, and consider replica shards R1, R2. In node 1, you have P1 and R2. In node 2, you have R1 and R2. In node 3, you have P2 and R1. Now, if one of these nodes or one of these servers go down, you will have a copy of all the shards, right? Imagine that node 1 is gone. So P1 is gone, but instead of P1, now people can read from R1. Question: should we keep the logic for selecting shards in one of the servers itself, or in a forward proxy, or in a reverse proxy? This is also related to what we learned in a previous session. Should we keep the logic for selecting shards in one of the servers itself, or in a forward proxy, or in a reverse proxy? Or you can start by answering, should I keep it in one of the servers, or should I keep it in a proxy? Let us decide whether it is a forward proxy or reverse proxy after this. It is a proxy. So now tell me whether it is a forward proxy or a reverse proxy. Again, it is similar to a load balancer, right? This proxy is in whose team? Who is setting up this proxy? Is it the client or is it the server? All this sharding, everything is at the server side, right? So which of these proxies is in a server's team and which of these proxies is in a client's team? We learned it in last class, right? Okay, reverse proxy is in a server's team. So here, will it be a forward proxy or reverse proxy? It will be reverse proxy, right? So best practice is to keep it in a reverse proxy. And assignment number 17, list down various sharding strategies than discussed here. And assignment number 18 for programmers, demonstrate sharding using any programming language of your choice. And assignment number 19, explore the concepts of sharding and replication with shards and replica shards in Elasticsearch. If you just Google for Elasticsearch architecture, you can find it. I still remember long time back, before all these Corona years, I had gone for a Elasticsearch official meetup, and then I had talked about this in Flipkart office. And I'm really missing those physical meetup days. So what is the leader election? So when you have few different processes running, and when only one of them should be actually doing certain things, you need to select that one, and that process is generally referred to as leader election. So when you have multiple processes, multiple distributed processes, and when only one of them needs to perform a particular task, you need to find that single one, right? And this task of finding that leader or finding that single process who will be performing that task has to be done by these processes itself. So imagine that I have 3 processes or maybe 4 processes. So these 4 processes have to communicate with each other and then tell, okay, one of us is going to be a leader. And other processes that elect this leader are called as followers. So if something happens to the original leader, then a new leader is elected. And how many of you have heard about this product called Zookeeper? So Zookeeper is a popular tool that uses this concept of leader election. And many of the Apache products with respect to data actually uses Zookeeper. And some of those products are Hadoop, Kafka, Solar, etc. Somebody has asked about Kubernetes. Here we have one more product called HCD, and HCD is the database that is used in Kubernetes. So we'll see more about Kubernetes and HCD in our Kubernetes session. Okay, algorithms that are used for leader election are generally referred to as consensus algorithms. And popular ones include Paxos and Raft. And Zookeeper and HCD are 2 popular tools that implement consensus algorithms. And Zookeeper and HCD are generally used for implementing distributed coordination and distributed key value stores. Zookeeper Atomic Broadcast or the SAP protocol is similar to Paxos, but they are not the same. And HCD is built on the Raft consensus algorithm. So there are many terms, and you may have to see these recordings more than once to keep all these things in mind, or maybe you can write it down and learn. All these terms are very much important. Whenever you are going for a systems design interview or a general systems design discussion in your company, if you are aware about all or most of these terms, you can really make a good impression among your colleagues or your interviewer or anybody around you. Assignment number 20, list down popular tools that use a consensus algorithm. Example, Zookeeper, HCD. We can add more to the list. Also popular products that make use of such products. So you can Google and find out what are the products that uses these consensus algorithms and what are the other products that use these products for their functioning. Polling versus streaming. So in polling, client sends a request every X seconds and server responds back. In streaming, also called as pushing, client listens continuously through a long-lived connection, and whenever a server has some message, it will tell client, okay, I have this message, do whatever you want with it. So in messaging, these are two approaches in which we can get messages from a system. So for certain systems, we'll have to always poll. And for certain systems, we have to just tell them that, okay, I am waiting. And whenever something is there, they will give it to you. So tell me, so which of these is better for a real-time communication? Whenever a message comes, I need to immediately know. It is streaming, right? In case of polling, I'll have to poll very frequently to get a real-time like response. The problem is that it will be too much of a burden for the server. So which of these you think is more secure? Okay, compared to streaming, many people argue that the polling is a little more secure, especially because of the long-lived connections in case of streaming. So if we need real-time updates, we may consider streaming. If you are okay to get updates in an interval, like in a dashboard, we may use polling. And while streaming provides you with real-time updates without need to make explicit requests, it also may introduce security risks due to long-lived connections. And polling or streaming is not better than the other. We need to choose the right one based on the use case. That is what we are learning in every slide of this systems design fundamentals sessions, right? Everywhere we have a choice to make as an architect. And the more breadth of knowledge you have, the more it will be helpful. You have to make trade-offs. Okay, assignment number 21. List down popular on-premises and cloud-based polling and streaming tools that are available, like Apache Kafka or AWS Kinesis Streams. There are many. So you can explore and then you can comment. So tell me, how many of you know the difference between a queue and a topic? So we are learning about messaging concepts now, right? Queue and topic are two very important terms. Many of you are going to learn Azure. In Azure also, many of you are planning to learn Azure Architect certification syllabus, which is AZ 305. So there also you will come to these terms. You will use products for messaging. And then understanding what are these things behind the scenes, things like topic or queue or streaming or polling can all help you learn those concepts much faster. That is why I always ask people to understand basic fundamentals of systems design and then jump into Azure or AWS or any cloud. But many people simply jump and then their only goal is to take a certification. But if you follow this route, you can definitely take certification as well as you can excel in work or interviews or wherever you go. Okay, when a message is sent to the queue, only one consumer should get the message. So if I have a queue and if I have 3 consumers, only one of them should be getting that message. That is how a queue works. And what about a topic? In a topic, there will be multiple subscribers. And when I send a message to a topic, all the subscribers will get that message. Some products can act as both queue and topic based on configuration. I will give an example with respect to a product, but I will not tell the name of the product. You can find it out on your own. I have a server or product that has a subscription mechanism, and I will give you a guarantee that if you are coming in groups or if you have something called as a consumer group, I will deliver message to just one of those members in a consumer group. So tell me, without changing anything on the server side, how can I create a queue-based workflow and a topic-based workflow here? So topic-based workflow can also be called as a pub/sub workflow. So how can I simulate a queue-based workflow and a topic-based workflow without making any changes at the server side? Okay, I will give a scenario. If I put all of my consumers into one consumer group, then will it act like a queue or topic? Queue means only one consumer will get the message, and topic means all consumers will get the message. And what is the guarantee my product is giving? Whenever you have a consumer group, only one of those will get the message. Out of a queue and out of a topic, which says that only one consumer will get the message. It is queue, right? So now try to think how I can make this setup work like a topic or work in a pub/sub workflow. What if I put one consumer in one consumer group? Okay, so if I have 10 consumer groups and I have a single consumer in each of them, how it will work? It will work like a topic, or will it work like a queue? It will work like a topic, right? Because it will deliver to all these consumer groups and it has only one consumer inside it. So effectively, all the consumers will be getting the message. But if all consumers are within one consumer group, based on my guarantee, only one of those consumers will get the message, and hence it will work like a queue. Previously, we discussed about sharding and replication. And if you look into the architecture of Elasticsearch, you will understand it better. And for messaging, you can look into many products, and Kafka is definitely one of them. So assignment number 22. List down and categorize popular messaging products based on if they work as topics, queues, or both. Again, explore and then list down. You don't have to know everything beforehand. You have to search. So another question. What do you mean by a denial of service? So we had learned about throughput and all in previous sessions, right? So if a system can handle only 10 requests per second, and if you are sending 100 requests, then that system will not be able to handle all the load. And some of those 10 legitimate requests might not get the response that they want. So they will be denied of their service. Okay, that is denial of service. And hackers can send multiple requests together to bring a system down. So what are some of the ways in which you can prevent it? A simple technique that you can use to prevent DOS attack is rate limiting. So rate limiting helps improve availability of systems. It limits the number of requests in each time period. And it will be based on some factors such as from a particular user or from a particular IP. So if I say that, okay, in 1 minute, I cannot have more than 10 requests from this same IP. Or maybe in 1 second, I cannot have more than n number of requests from the same IP. And sometimes in real world, you may configure multiple rules. You may say that, okay, in 1 minute, I don't want more than n. And in 10 minutes, I don't want more than maybe x. The reason is because if your rule is only telling, okay, in 1 minute, I can have only 2 requests, what these hackers they can do is they can send every 1 minute. And most of the cloud providers will provide you a lot of options to configure all these rate limiting capabilities. And it helps to prevent DOS attacks. Good to have an external system do the rate limiting configuration. And you can combine multiple limits together, like the one I said, maybe 1 minute a limit, maybe 5 minute a limit. You can have multiple limits. As assignment 23, you can list down popular DOS or DDoS events that happened in the past. So now tell me, what is this DDoS? DOS is denial of service. DDoS is distributed denial of service, which means that even if you have configured rate limiting based on IP addresses, now hackers, what they will do is they will do it from a lot of different systems, lot of different IPs from all across the globe. So simple IP-based approach will not work here. That is why many cloud providers and all are coming up with solutions based on machine learning and all. And so one more important factor that you need to consider while designing systems or creating architectures, you need to have proper logging and monitoring. It can help in security. It can help in availability. Some of the examples are number of logins per hour, important operations per hour, etc. And for this logging and monitoring, many people use time series databases. We did not discuss much on time series databases when we discussed NoSQL databases and all, right? So examples include InfluxDB, Prometheus. Prometheus is a very popular tool these days for logging and monitoring. And you can create good dashboards using products such as Grafana. Especially for the security purpose, you can also integrate alerting when some of these happen, maybe a Slack message or something, so that you can take some actions. Most of the clouds, you will have option to create logging, monitoring, and alerting and all. And assignment number 24, explore and list down popular logging and monitoring tools that are available in market, such as Prometheus. So if you really follow these systems design fundamentals sessions and do all the assignments, you can definitely become a better architect. And if you are already an architect, you might get a feeling that if I had known about this, then I would have done something different with that particular use case that was presented to me at work or that was presented to me at an interview. There is more to explore. So we have to explore about static versus dynamic configuration, its advantages, disadvantages, and all. We have to explore about storage, terms such as content addressable storage, immutable blobs. We need to explore more about time series databases. I want you to come forward and pick up a topic, and then I want you to deliver. Don't just make it as a one-man show. Let us all learn together and then let us all grow together. And some quick questions you can ask yourself while preparing design. What is RTO and RPO? We learned about RTO and RPO already, right? And the number of users and data per user, or identify the sharding key or partition key. That is also a very important thing that you have to do. So whenever you are having this horizontal partitioning, you have to select your keys or sharding key or partition key very carefully. Otherwise, you will end up in something called as a hot partition. So imagine that I have 10 partitions and I choose a very bad partition key. And since I have 10 partitions, I have allocated my computer resources accordingly. But because of my bad partition key, all the data is going to only one partition. And other partitions will be sitting idle without any load. Okay, this scenario is called as hot partitioning. I still remember when I started working with AWS DynamoDB at the beginning, we used to struggle a lot with respect to the issue of hot partitions. And you can ask whether I need to have load balancers or proxies, or whether I want to use service discoveries. This was an assignment from the previous session, right? And should we be developing for web, desktop, or both? And always look for the expected throughput. Example, 10 requests per second or 30K concurrent users. Are we going to design for a particular region or across regions? These are just some of the examples. Assignment number 25. You can prepare a checklist you can use during systems design or while preparing architecture specific to your areas of work or interest. And this assignment you have to do after doing all of the other assignments. Maybe you can skip the coding assignments if you are not a developer, but all of the non-coding ones. And then everybody should have a checklist on their own, and then they should improve upon it. Okay, it can really help whenever you are having a similar problem at work or in an interview, and then come forward and present it to our study group. And maybe others may be able to provide better suggestions on at least some of these points based on their experience. People say that you learn from your mistakes and experience. But the fact is that there is not enough time to learn from only our mistakes and only our experiences. So you have to also learn from others' mistakes and others' experiences. And a community study group is the best place where you can learn from others' mistakes and others' experiences without having to worry about somebody rejecting you from job or somebody having a bad impression at work. And that is also one of the reasons why I created this portal called cloudrix.com along with our study group for anybody who wants to learn without getting distracted by the ads. Because we have a Facebook group, but Facebook has a lot of ads, lot of distractions. So if you are somebody who does not like all those things, does not like Facebook, you can definitely explore cloudrix.com. So behind the scenes, we are currently using a portal called as circle.so for managing the community. So Facebook makes money through ads. Here we pay a subscription to continue running this platform. And part 4, existing systems. Let us start with student presentations. So again, few more pointers to existing products that you can start preparing for: Kafka, Amazon S3, or Docker, Kubernetes under containerization. And under distributed computing, you can explore MapReduce, HDFS, GFS, Bigtable, etc. There is no limit to what you can explore, and there is no limit to what we can explore together in our study group. Suggest more topics that we should discuss as part of our systems design discussion under this video. So part 4, you are going to take, and I am going to guide you. We had a pretty decent number of sessions as part of this systems design discussion itself. And please share your feedback in all our groups about all of these systems design discussions so that it will encourage others, it will encourage me. Thanks a lot for attending today's session. Let us all learn together and then grow together. My only humble request is to come forward and take sessions, and let us all learn together, and then let us all grow together. Bye-bye for now, and see you all soon.